Hello, everyone. So I stand between you folks and high tea or dinner, so not a very, it's a bit scary, but oh well, I'll try and. Okay, great, great. Uh, just wanted to acknowledge the topic champion for this talk, Sucharita Chaparam of the Intuit IEDC. She presented this topic in the proposal stage. Unfortunately, she couldn't be here, and I have the honor of presenting this topic. I think monolith or microservices, more and more devs and engineers are moving to microservices-based design. And I think if you look at the core attributes of why microservices are so prominent, it is really the fundamental fact that you can now update your service in potentially milliseconds, seconds, and no longer things that take hours or days or weeks. And I'll kind of talk about why that transition has happened. Right? So if you are in some sense struggling with either an existing application that takes days to deploy and stabilize, it's hard to perturb the design because you have this big monolithic service, or you're trying to build a brand new service ground up, I would highly recommend that you tune in. I think we'll learn a few very interesting things about this new paradigm, and hopefully something you'll consider and keep in mind as we move forward. Some of the key session objectives, I think we obviously want to introduce the topic and talk about the key principles, what are microservices. I'll briefly touch upon how they relate to containers. I hope a few of you at least were able to attend the container talk this morning. So this is more like how do they relate to each other. And then we'll briefly talk about the Mesos orchestration framework, and I'll spend probably a slightly longer time talking specifically about the Azure Service Fabric architecture. Right? Some key takeaways, I hope, at the end of the session. If you are building scalable, complex, large applications or redesigning existing ones, you'd consider this architectural approach. And I also think I want to introduce you to a bunch of platforms or orchestration frameworks that really make this a very compelling kind of direction you folks should consider. So let's start from the very beginning. I think the picture on the rightmost corner kind of talks about the journey of software for a bunch of us who've been in the industry for many years. We've probably seen all these transitions. For a bunch of the millennials on the cloud, you probably have only seen you probably missed the left one that I'm going to talk about. But the typical kind of waterfall model, right? Like where methodologies, the process is gated, it's a waterfall model, two-tier monolithic applications, typically the platform's Windows, device is the desktop, right? And so a bunch of you must obviously be familiar with the agile model where it's a Scrum-based process, three-tiered layered, Windows, Linux, browser-based interfaces. And that's been probably what's been happening over the last 10 years. But when you look at the disruption that the cloud is bringing to the market and to the industry, it is dramatic in terms of the need for continuous delivery, right? Just last night, my team out in the Hyderabad Dev Center was asked to kind of re-provision a particular, my team in the India Dev Center builds the Azure Cloud Backup Service, and we were asked to re-provision our storage accounts because we were having some issues on kind of the amount of ingress into the storage accounts. So we had to, in a sense, react and respond and redeploy this service in a matter of minutes and hours, because otherwise this would have turned into potentially custom outages. So this entire direction of the cloud is pushing all of us into the continuous delivery model where it needs to run on any device. And also the sheer scale, if I kind of look at IoT-style applications or other applications where there's so much of sensor data, the sheer scale and resiliency needs have gone up dramatically. And it's super crucial, especially in the cloud world, to build for both scale and resiliency. One of the key principles in cloud-based design is that you design for faults. By definition, you need to take account of the fact that clouds are built on commodity hardware. Their failure rates are much higher than traditional on-premise, these SAN storage boxes that have obviously lesser degrees of kind of failure in some sense. And since you have to now design for failure as a key design point, you need to start considering architectural paradigms that offer you both scale and resiliency. And that's exactly what I think microservices is going to do for you. So let's kind of start with very specific, what are microservices? To me, microservices, in summary, microservices do one thing and they do it really, really well. If you have a stapler, it staples a set of sheets of paper together. It doesn't do anything more than that. Less than that, maybe you can throw it at your husband. But that's but it's pretty single purpose. And that entire kind of single responsibility principle is at the core of what a microservice is, right? It's a self-contained unit of functionality. When you think about microservices, if you think about a large application, you most likely have multiple loosely coupled dependencies between these services. And the key aspect of microservices compared to monolithic ones are that they tend to be fairly isolated, which means that you really are not optimizing for efficiency. It's not like you're trying to say that I'll write this code and I'll write it only once. You're optimizing for speed, right? Which is exactly what Netflix did when it had to kind of handle the number of users that they had with kind of the entire kind of video streaming applications that they have to kind of go and build. Microservices are also by definition elastic, as in they can be stateful and stateless, but the key thing is they can be scaled independently of other services. The same cloud backup service, special shout out to some of the engineers who work on that service. For instance, in geos, in specific geographies where we have a lot of ingest of data, we have to scale up or kind of auto scale the number of roles that we deploy depending on customer load, right? And so microservices, by definition, it's relatively easy. You can literally walk up to one of these frameworks and say, deploy me a service with like 10 instances with these kind of scale characteristics. And the underlying framework will allow you to deploy these and scale these up and down and do load balancing and partitioning and a bunch of these other capabilities. We talked about resiliency and why is it super crucial for microservices to be fault tolerant and highly available. And the last point is pretty crucial, I think, especially with devices and IoT type applications, it's super crucial for the cloud to be super responsive. You have obviously all the challenges with respect to latency, whether it's storage latency, network latency, and a microservice in some sense needs to respond in a very reasonable amount of time so that the end-to-end latency of your app doesn't grow. I put on a few more attributes, I think, which I think are important, but I'll highlight a few of them. They tend to be message-oriented, and in some sense, this is similar to the service-oriented architectures where there's a lot of message passing, async kind of message passing between components. But they also, the other kind of key attributes, of course, are that they're both programmable for the developer and for the admin, right? So for instance, the developer gets an API that can be used to program the microservice, and they also provide a console or an admin API that administrators can use for administrative operations. And the last point, I want to belabor that because at the end of the day, the only way you're going to get the level of flexibility, or I would say even the timeliness, continuous delivery, is unless you automate every aspect, whether it is build, test, staging, production, and distribution, you're going to spend a lot of time. If you ever have a deployment that has manual steps, it's error prone, and so microservices lend themselves. In fact, these app frameworks are highly optimized to kind of have automation support. So I hope I've already kind of convinced you why you need to think about it, but I think very quickly I'm going to talk about what are the benefits of such an approach. I think the key aspects are that an existing monolithic service can coexist with a microservice. It's not like you need to rip and replace and throw out your entire monolithic service and bring in a brand new set of microservices. You can build new functionality and bridge to a future state. I want to use an example closer to home. Recently, for instance, the team I'm working on, we ended up having to rev the telemetry data points that our service receives. And previous designs of this, the telemetry data service required us to redeploy a much bulkier monolithic kind of service. So what we did is we ripped apart the telemetry and put it into its own kind of pseudo microservice, not a true microservice yet. But the key thing that we did is all the aspects of the underlying schema that go together, all the metadata that needs to kind of go together, we pulled it apart, decoupled it from the core monolithic service, and now we have the core monolithic service running in conjunction with this brand new kind of microservice, right? So this is key to the approach. It's evolutionary. And typically the APIs are language agnostic. You can program it using REST, SOAP, highly decoupled, and very resilient. There's no one single point of failure, no big monolith to kind of fall over. And I think the key aspect, of course, is that speed of development, right? I think really the velocity has become super crucial in this brand new world that we're in, and reuse and composable. And of course, the last point I want to talk about this, and I'll talk about this a lot in the coming slides, which is much, much higher deployment density, right? Like for instance, if you can imagine a monolithic service, in fact, the next slide kind of talks to that. So a traditional, very poor resolution. Yeah. Can you folks see it? Yeah, I apologize for the poor, I don't know why the font is showing up the way it is, but anyway. A traditional application, the one that you see on the left, is kind of composed of all the pieces of code pretty much sitting in one big piece out here. And the way we do this is we kind of clone the application into multiple containers, right? So all the pieces, typically it may be that the app is layered within, internally, but the app is deployed in one big package to multiple containers. And so it's fairly coarse-grained in terms of how it's deployed. And you also need to deploy the full application. You can't deploy parts of the application. If you deploy, there's no way to deploy half the application. It will disrupt. There's just no way you could do that. The key thing with the microservices is that you have now split your monolithic service into independently deployable, almost baby services, right? And now you're able to scale them out by independently deploying them on all the container nodes. And also, if you notice, you can potentially pack more of these microservices per container. When I say container, I mean the execution container. It can be a physical machine, a virtual machine, a container itself, right? And so any execution context, you can pack many of them together just because they're much more kind of fine-grained, right? And allows you to optimize it that way. And of course, the scale out also tends to be much more independent. And we'll talk about the scale in a few slides. A traditional application on the left, like you have a typical 3-tier model with a single monolithic database at the bottom. That's fairly, like it's a stateful application. Whereas with the microservices on the right, you potentially have two approaches. You have stateless services, like the ones on the left, where you have related databases, where the state lives outside, say on cloud storage, or say just take a document DB or any kind of infrastructure outside the core service itself. Or you may also have this notion of stateful services, right, where you have state within the service itself. And then you use some notion of kind of local state replication to kind of achieve the degree of scale and resilience, right? So I just want to kind of contrast a typical 3-tier approach with a database outside with the microservices approach, where you end up having a UI presentation layer that's then composed on top of either stateful or stateless services. And we'll talk about this as we go down the road. There's one slide that's just okay. I'm just going to talk to this. It sounds to me that there's like one slide where I was trying to contrast what a virtual machine looks like and a container looks like, just to kind of get the context right for the audience. The key thing with VMs, of course, is that since you have a hypervisor, you're now able to kind of provide a machine virtualization layer, right? You're able to run the entire guest OS within the virtual machine boundary. but then the entire guest OS is kind of replicated across both between the different virtual machines. The key thing with a container, of course, is that you now have, you all share the same host OS, correct? You don't have your entire copy of the OS for yourself. That's the key difference. And you also now have like potentially like something like the Docker daemon, where you're now running your Docker containers on top of the Docker daemon layer, and you have shared binaries and libraries. So this means that you now have a much lighter weight virtualization context, and this allows you to dramatically decrease the amount of time it takes to deploy. Right? With the virtual machines, the fact that you have the bulky guest OS layer means that your deployment time is in multiple minutes, whereas with containers, you have now shrunk the deployment time. So in this slide, I'm going to talk about how I think microservices can be leveraged, or containers, sorry, can be leveraged for microservices. And to a large extent, I feel that the benefits of a container almost get magnified. I think containers can be used to host both monolithic applications and microservices applications. But to me, containers, microservices architecture really make the Docker container or a container approach shine, in essence. And the reason this is because containers offer a very natural, if you remember the previous picture where you ended up packing many of these microservices on a single execution context, you really need to have a very strong isolation boundary, right? You need to be able to have a fair resource allocation between the various processes. And I think both the namespace and resource isolation characteristics of containers lend themselves very well to a microservices approach. And of course, the benefit of using containers is that now you have the entire Docker ecosystem, or a container ecosystem in some sense, available for both the developer of the microservice application and the operator of the application. So in conclusion, I'm essentially going to say that we believe that with a container approach, management and deployment and patching needs of a container-based application, container-based service are best achieved, with the least loss of availability, right? With the reduced risk of availability loss. When I talk about availability loss, it means what happens when a node goes down. And so the point I was trying to make is that a container-based service which uses a microservices approach is probably going to be the most resilient and the most highly available, right? So when you think about containers, also in conjunction with containers, do consider your approach, whether you want to still put a monolithic application on a container, or you want to kind of potentially shift to a microservices-based approach. We're going to switch gears slightly. How much time do we have? I have time, okay. And we're going to spend some amount of time talking about what I call orchestration frameworks, right? So when you think about microservices, at the core of it, these are services that have much smaller footprints. So now you're not going to need an orchestration framework that allow you to kind of deploy these applications at large scale, right? Like for instance, if you can imagine what is powering Amazon.com or Netflix.com, or you think about all those big websites out there, I think you literally need to have jobs and tasks that run on hundreds and thousands of nodes, right? And so you really need an orchestration framework that allows you to kind of farm out tasks or jobs to thousands of nodes. And so I just picked the example. There are many out there. I think there's Apache Mesos, there's Kubernetes by Google. I'm going to talk about Azure Service Fabric. So there's many models out there. I just thought I'll give you folks a flavor of two of these, just to give you a sense of how this works. So Mesos, at the end of the day, is really an open source cluster manager, right? That's what it is. I think this morning there's a very interesting talk on Cloudman, which again seems to be in that same space. It's really around being able to abstract the underlying hardware, right? And you're giving folks an API, a full API for programming the underlying kind of data center layer. And the way you do this is by, there are four major components in a Mesos cluster, right? You have the Mesos master. The Mesos master essentially has it has kind of like a single system view of the underlying capacity that the Mesos slaves in combination present, right? So each Mesos slave registers with the Mesos master. You see the slaves on the right that register with the Mesos master and essentially advertise their capacity. And the Mesos master is, you run a set of 2 to 3 nodes in a given Apache cluster, Mesos cluster, that allow you to kind of now schedule, place these jobs on these various Mesos slaves, and also like monitor them, monitor their health and execution. And you also have this notion of what we call the zookeeper on the bottom. And the main aspect that the zookeeper does is it does leadership election, right? So when you have, especially in a distributed system, and when your leader that's placing jobs onto various nodes kind of go down, you need to have leadership election. That's something the zookeeper does. And more importantly, the Mesos master kind of works with what are called frameworks. In this case, Marathon is an example of a framework. Apache Spark is another framework where you can essentially, the programmer programs against these frameworks. They're kind of abstracted from the Mesos master, but allows them to kind of essentially submit huge number of kind of jobs that finally get executed on the Mesos slaves. So now, as you can tell, the fact that there's really an entire API that is a distributed kernel gives you brand new type of applications that you previously couldn't build. And that, to me, is fascinating. I mean, this is stuff that has come together in the last few years. I mean, a huge open source community behind it, and I think it's really, really powerful. Full confession, next few slides are going to be a shameless Azure Service Fabric based. I figured I'll delve deep into some of that just because I probably have access to more details on that front. But I also wanted to talk about why I think in this brand new world, every cloud out there has to offer open choice at every layer, right? No cloud out there can really take a very, I'd say, vendor-specific view anymore on the matter. And if you can see the picture on the left, you see that the Azure public cloud and the Azure consistent private cloud with this notion of VMs and scale sets does support Mesos, Swarm kind of infrastructure on the left, and also like frameworks like Marathon and Gelastic, and the service fabric that also offers, it's really a platform as a service offering out of Microsoft that allows you to program a true microservices-based application, and we'll spend at least the next 5 to 7 minutes understanding exactly how it does that. So what is the Azure Service Fabric? So what we did is, when you think about a bunch of kind of apps that we have out there, right? Like we have the Cortana backend. Cortana is what goes on our Windows phones, our personal digital assistant. Or if you think about Azure SQL Database or Skype for Business, a bunch of these backends were built on PaaS, underlying platform as a service application. And so what we did is we took this battle-hardened technology that's been in production for the last 5 to 6 years, and we've decided to kind of now offer that same battle-hardened technology that we use to kind of handle Azure SQL and a bunch of the underlying Azure infrastructure and offer it to developers. We'll go GA. We announced this recently. But the key aspect is that this is the foundational technology that we use to run our own entire Azure cloud infrastructure, right? It powers the most complex, low latency, data-intensive scenarios. As you think about scenarios like Netflix and other scenarios based on microservices, there are equivalent examples that we have, like for instance, the Azure SQL database that has 1.4 million customer databases, or Bing Cortana, which has around 500 million evaluations per second, right? So these are extremely intensive applications that need to have extremely strong scale characteristics, and the Azure Service Fabric is exactly an attempt at doing that. So what is the Azure Service Fabric? At the core of it, the Service Fabric offers very similar to Mesos, right? It lets you load balance, partition your applications onto the cloud in a declarative manner. You can literally walk up to the fabric and say, I need n instances of this particular microservice. So the underlying kind of building block for Azure Service Fabric is still a microservice, right? So you need help in placing these. You want to kind of place these where you have the right proximity to your data. For instance, if you want compute and data proximity, it will be able to understand those capabilities. It has high availability. It has local state replication because, and I'll explain why we need some of these capabilities. But at the end of the day, it also like differentiates from existing offerings out there because it has, in addition to a bunch of the other orchestration capabilities, it also has automated lifecycle management for microservices. So it's front and center built to optimize for microservices. And there's very kind of core capabilities that, like for instance, rolling upgrade. How many of you have handled things where you have an entire monolithic service out there and you need to rev parts of the service, right? Can you do this in a manner where, is there any world out there where you can suddenly rev every part of the application from version n to n+1 in one fell swoop? Doesn't happen, right? You need to have a process where you can essentially support rolling upgrade. So a lot of these key capabilities, because these are real-world problems that we have faced deploying these large-scale services, we've taken those capabilities and put them into the Azure Service Fabric as core primitives, and that's really kind of what we'll talk about. With this, I'm just going to talk about how the Service Fabric cluster works. We looked at the Mesos example a few minutes ago. So with the Service Fabric cluster, you essentially compose what is a cluster with n machines, right? And these could be n containers, it could be n virtual machines, n physical machines. The Fabric cluster can be composed that way. And let's just say you have two applications that get deployed onto the cluster. And let's just say that the node on the right is going to fail, right? So then the Service Fabric automatically rebalances and repartitions that microservice into other nodes. But the one thing that you noticed is that when you placed these microservices onto the cluster, it automatically did local state replication. It automatically created resilient copies, which means you don't have single points of failure. And that is the core. With commodity hardware, the only way you're going to design for faults is by building resiliency and replication into your design. And that's exactly what the Service Fabric does for you. So each node in this is just a VM. It could be a VM, right? So depends on what your deployment looks like. So each app out here, each microservice out here would get deployed onto these nodes, and then the state would get replicated. You'd place one copy and you'd have replicated copies of those. And we do this for both stateful and stateless microservices. I'll talk about that in a few minutes. Again, to summarize, key capabilities of the Fabric. We support, we optimize for application deployment. So the key thing is we want to kind of get these deployments up in seconds, milliseconds, and not wait for hours and days or weeks. I mean, that's unfortunately been the current, if you think about the state of the art, we're still not down to seconds and milliseconds, but the reality is we need that capability. It allows very strong versioning support. And that's what a microservice is. It's autonomous, and it's independently versionable and scalable, right? That's the key attribute, and all those are kind of built in. I talked about the leadership election problem, the previous thing where one node fails, you now need to replicate or rebalance the cluster. Automatic kind of partitioning, load balancing support, and also like a state replication. Every time you think about a stateful application, there's a whole bunch of state that's built into the microservice, into that container itself. And that's also something that needs to be replicated. I'm just going to briefly talk about the current Azure Cloud Services, the current, what we call the PaaS, Platform as a Service V1 model that's out there for a bunch of people that are familiar with Azure that use web and worker roles. The one on the left, where you have one service instance per VM, right, with this very uneven workloads, and the compute density is low because for each one of these worker roles, you're putting it in one container. Whereas the picture on the right with the Azure Service Fabric really allows you to kind of put multiple microservices into a single, so there's a much higher density that you can achieve during deployment and much faster scaling, right? So this is, the one on the right is what we call the Azure Service Fabric based or the PaaS V2, Platform as a Service V2 offering that that's being built as we speak. And I think the key value is the fact that the one on the right is completely optimized for microservices. It's really a very, I would say, nimble way to kind of build high-scale resilient applications at hyperscale, right? The world out there has gone to hyperscale, and I think I'm getting the timeout from my colleagues. So should I skip probably to answer questions? So let me do this. There's tons of fabulous reading material out there. I'm going to point out this reading list. There's the one by Sam Newman on microservices. There's one very interesting thing that I read about as I was preparing for this talk, which is this notion of Conway's law. If you have, Conway's law essentially states that an organization, when you work in a committee, then the organizational structures is kind of reflected in the structure of the work produced by the committee, right? So the interpretation of this is, for instance, if you had 4 teams working on a compiler, you're likely to have a 4-pass compiler, right? So this is called Conway's law. And the reality is that with monolithic applications out there, you may start off with a very layered presentation layer, mid-tier, and a database layer, but over time it becomes very siloed. It's hard to rev these, it's hard to version them, it's hard to upgrade these services. And so in some sense, microservices, by kind of autonomously scaling, autonomously versioning these and making it independent, we've tried to address that particular constraint. So with that, I hope you're going to walk away, whether you're going to build a brand new application or rev an existing one, please consider the microservices approach. And there are tons of open source and other applications out there that really help you do this really well. So with that, I'll take some questions.
Hi. So breaking a large monolithic service into microservices essentially seems like sharding data in a huge database, right? But how much is the effort involved to actually break a service? Like generally for all databases, sharding is automatically done by the database itself.
I don't know that I think they relate, they're slightly different, right? I think sharding is essentially allowing you to take a large namespace and partition it.
But yes, correct. It's like breaking a large data, but then again, sharding also employs the same principles of data replication and leadership. All those things remain the same.
Fair enough.
But the point is, sharding comes automatically out of the box. But to break my large service into chunk of microservices, how much is the effort involved?
I think it would, mileage may vary depending on the complexity of what you're breaking up and complexity of what you're picking up. I think what is very effective is, for instance, there's this thing called like a 2-pizza team, right? Like if you have a team where you can feed the entire team with 2 pizzas, that's probably a good size for a microservice, right? The code produced by this team. Now, if you take the schema that represents the underlying backend for that particular microservice, if that schema can be independently, they're tied together and they can be independently revved without perturbing the rest of the service, that's probably a good way to define what you call your microservice, right? And so I think it totally depends on whether you're trying to break, like in the example I used where we're trying to break telemetry out of the cloud backup service, that was relatively simple because the telemetry APIs were independent, right? So the effort is to like decouple, right? But also provide API surfaces on both ends that then will now, so there will be that effort, but it's effort worth your while. Right?
Okay, so it is like how much is the schema loosely coupled, plus at what level are the services coupled?
Exactly. Yeah. Absolutely, it's at the core of it is a very simple principle, the single responsibility principle. Microservices do exactly one thing, and they do it really, really well. Exactly, yeah, and don't have them too bulky, right? And that's really so it's a very simple set of like, without a doubt, yeah, without a doubt.
So currently we are on Azure and we are on a service-oriented architecture. If I have to move to Service Fabric, right, it should not be too much of a change for us, I guess, right? Because we are already on a service. It might not be. We are not on microservices as such. We have but independent components which are like deployed separately anyway. But for us, if you have to move to Service Fabric,
it sounds to me, yeah, I think you'll have to now evaluate how you want to pass V1 to V2. I don't know, are you a pass application today?
Yeah.
Yeah, I think pass V1 to V2, I'm sure there's guidance out there on how we want customers to move from pass V1 to V2, but it sounds to me that if your underlying service already is neatly abstracted, that should be hopefully
So
a
the
smoother
additional
transition.
thing which I get from Service Fabric when compared to the cloud service that I'm having is more from in terms of for deployment easiness and things like that.
Deployment, automation, the fact that you can monitor the health, right? And the fact that the Service Fabric, you don't have to worry about BCDR, right?
Yes.
It does so many, it is designed for faults. You don't now have to, typically with the PaaS, you're probably showing up with 3 worker roles or 3 web roles just to kind of have the right update domain, fault domains, all that is,
Okay.
right? So in some sense, you've now eliminated that problem because underlying Service Fabric, you walk up to it with a declarative description of saying, here's what I want, and it gives it to you, right? It's a service offering.
Any other questions?
Uh-huh.
And we are planning to go to services route. So let's say I'm having 100 different microservices. Are you telling
100 different?
100 different microservices that I can abstract out? So is it that I have to deploy 100 wars across my nodes? How exactly will the deployment involve?
So you would deploy each microservice independently, yes. Each microservice will have an independent deployment. So you need to think about, do you want hundreds of these? You need to make it not too fine-grained. I think there's a fine line.
But ultimately different wars.
Yeah, different deployment, absolutely. Absolutely, yes. Yeah, no, so I think, let's be clear, right? You aren't optimizing for efficiency of code. You're not sitting there saying you're going to, if you achieve that separately, that's probably a good outcome, but you're optimizing for speed of delivery. You want to continuously deliver your code. That's really what you're attempting to do.
I just want to ask one thing. What you said that one thing, one node or one container goes down, the other web services gets deployed to the other containers which are available. So I want to ask that how that is handled. I mean, there are multiple containers. There may be multiple containers, and you want to have the same web services going down, and the microservices going down, like per se SQL. So if we are moving the same SQL to another one where it already exists, the SQL one already exists. So how that balancing will be done on that same container?
Typically with an Azure SQL or SQL type application, you're going to have that microservice itself is going to be stateless because it's connecting to an external database. Correct? The database is also highly available. It's also incidentally built on a PaaS framework. Correct? So there, the particular service that you have is just the mid-tier logic, right? So that should be idempotent. You can tear down one of these. There's a very interesting analogy out there. It's called pets versus, I think pets versus cattle, which we should make sure that it's in the context that we have, which is typically with pets, you kind of groom your pets, right? Monolithic applications, you groom your pets. Whereas with cattle, like one of them go down, right? You just bring up more of them. Right? So it's a very kind of so you need to essentially think about that notion that stateful versus stateless. We didn't have time to cover that, but it really is around the fact that in that SQL example state is external to the service itself.
Hi, I wanted to ask that in a single service, monolithic service, all the processing happens in a single process. So if we break down the service into multiple services, so there would be multiple processes.
Yes,
So
and you
would
have
that,
message passing.
put an overhead of inter-process communication.
I think
and,
it is a trade-off. I definitely think you're doing a lot more kind of message passing. But then when you think about it, do you want to, you trade that off versus autonomy, right? Can you bring in like a service written in Node.js sitting right next to a service written in completely different technology? Right? Those are absolutely, it's completely open technology and as long as they talk the right API surface that's not specific to a particular implementation. So I think it's a trade-off in my opinion. But what we've learned deploying monolithic applications is the minute you kind of find it hard to update your bits in the service, then your agility as a company has gone down dramatically, right? Like I'll give you an example of a company, a software company that does a bunch of, it's an IoT application. They incidentally have built their microservices-based architecture on Azure Service Fabric. They have 450 source data types where the sensors are bringing in data from their current on-premise software that they have. And when they moved to Azure Service Fabric, they had an unprecedented growth in scale that they were able to achieve by using the Service Fabric, right? So things that you couldn't do before are now you're capable of doing just because you now have access to infinite compute. One biggest change that we don't realize that we have designed software for the last many years with the assumption that compute is expensive. The cloud has fundamentally changed that assumption, which means we need to fundamentally rethink how we build, correct? And that is, to me, so when you rethink that, things that you didn't think you could achieve before are now you're capable of achieving, right? And this particular company had a very dramatic shift in its scale for the IoT type application that they were building.
Yeah, hi. It's regarding the whatever you told. If one node is down, then that will be removed and the other applications will be deployed. I mean, how do you think that is more advantage than doing a health check on the node and autoscale on some other VM rather than deploying the applications in the other nodes?
I think it's the agility of how much downtime do you want, right? A typical monitoring-based approach, even if you look at kind of clustering where you have a witness and your witness server is constantly receiving heartbeats from your nodes, and then you don't receive a heartbeat and then you fail over. I think it's really kind of a trade-off between the degrees of replication that you're willing to spend on versus, I think it's really on automatic versus automated failover also at some level. So I personally think if you have smaller pieces like a microservice, it's much easier for you to fail over very quickly, right? Whereas if you have a bulky service, it's much harder to kind of fail over.
Yeah, it's, I mean, more than microservice, we might need a 5 VM to handle the load. So if you're deploying it to the other nodes, then they might not be able to handle the load or something like that.
No, but that's exactly why you have an orchestrator in the middle that does load balancing, right? That it's intimately familiar with the capacity on these nodes. And just be clear, if it doesn't have capacity, it can fire up more VMs or containers or whatever it needs.
Okay.
Infinite scale. I mean, that's the beauty of the cloud, right?
Thank you.
Any other questions? I hope the talk was useful and you folks walk out with a microservices, here we come attitude. Looking forward to, if you have any questions, please do walk up to me. My email ID at Microsoft is charun, CHARUN, N as in Nancy. So please drop me a note if you're looking for any more information. So thank you.
Thank you, Charu. And now I'll request Bharti to do the.
Thanks. Thanks, Bharti.
Thank you, everybody. Have a great evening.